So we got a factory worker pushing the crate. Okay. He's pushing the crate this way with a velocity that is constant, which means acceleration is equal to 0. Okay. We know the coefficient of kinetic friction is 0.25. And the distance that he pushes it, S, is 4.5 meters. Okay. It has a mass, but who cares, of what? 30 kilograms? Didn't give us a velocity, so it doesn't really couldn't calculate kinetic energy. And that's the thing now. It's time out. Time out. Well, Mr. Shields, there's no force because there's constant velocity. There's no acceleration. There's no force. Yes, but it's moving. So is there energy? What kind of energy? There's kinetic energy. And what do we remember about kinetic energy? Kinetic energy, the change in kinetic energy is equal to what? Work. Total. So you can't forget about kinetic energy. See, it threw the mass in there, and that right there ought to set off an alarm like, oh yeah, there is kinetic energy because it's moving. Okay? Well, it has kinetic energy. Okay. So, what is the question again now? It says, what magnitude of force must the worker apply? Okay, well, we know there's a frictional force, right? So what do? 0.25 times 30 kilograms times 9.8 meters per second squared. And you get a frictional force of what? 73.5. Newtons, right? Okay. So now, all right, now how much should he apply? Well, is the application force in the opposite direction of friction? Yes. But typically when we're moving forward, whatever force or velocity or acceleration is always given what kind of value? Positive. So, okay, then how much work? Okay. Well, all right, y'all. How much work will it take for the person to push the crate? Okay? Well, that right there is the kinetic friction force. And what do we remember about kinetic friction? That's the friction that occurs during motion. All right? So can we do this right here? What was it, 4.5 meters? Cosine is 0 degrees. And we get what? 330.75 joules. So this is part B, right? So that's part A. It's part B. Part B says how much work is done by the crate by this force. Okay? 370.75 joules. Now, what would be the force of friction? Excuse me, what would be the work done by friction? The negative of that value. So that's part what? C? So the work done by friction is equal to what? Well, you take that value and just make it negative. And wait a minute, Ms. Shields, why did you do that? Okay, y'all, because it's not accelerating. It is moving. There's kinetic energy, but it's not accelerating. So that means there's not a net applied force. There's work done by kinetic energy, not by an applied force. Does that make sense? Okay? The work's done by kinetic energy, not an applied force. Okay? All right, so what is the work done by the normal force and gravity? Does it ask you that? How much work does gravity do on the car? No, excuse me. How much work is done by the normal force and then by gravity? So part D, come on y'all, do I even need to write that down? 0. Both of them. Why? Look y'all. Force normal. Gravity. It's perpendicular. Cosine of 90, cosine of 270 is 0. All right, now what about E? Work total. Is it work total? What is the total work? Okay. Well, that's right. You've got the final, let's see, kinetic energy. Okay, so we got 330.75 minus, all right, now wait a minute, let me think. Yeah, the work done by friction, okay, minus 330.75, work total is 0 joules. And really the best way to describe that would be network. Okay. All right. Does that make sense? That would really be the best way to say that, the total work, because that's a little deceiving. You say, now wait a minute, there was 330.75 joules of work forward, yeah, but there's also the frictional work done that's the same value in the opposite direction. That's against it. So you got to be careful when you listen to that total work. It's really asking for net work. Okay. The object's moving, but there's no net work. Okay.
So there's no acceleration, does that apply all of it?
Yes. If it's moving at a constant velocity, the work done by kinetic energy is all there is. There's just no net work. Now, if you change the velocity, then yes. Okay. In other words, all the work done is by kinetic energy. It's not gaining or losing. In other words, there's no positive work. All right. It's almost like saying constant work, almost. Almost. All right. Okay, y'all, I think that's a good stopping point. Y'all work on these problems, and we'll look at some more of these next week. And be ready, I may call on some of you to come up and work some on the board.